Dear students, today we are going to learn about theorem number 3. The number of permutations of the n objects where p objects are of the same kind and the rest are all different. Nangonda piriba objects sigi marakta masak manaba yauramagadi object se repeated oiba yauramagadi ko nangi total number of permutations se kaina pirakani n factorial divided by p factorial na p neba nangi permutation puthokadu se n objects ni ko n objects sigi manung the p objects se manaba yauramagadi p objects are of the same kind p objects se p nangi object kharadi p times si repeated oireba doitardi total number of permutations se kaina pigani n factorial divided by p factorial sina pireko. Then theorem number 4, the number of permutations of the n objects where p1 are of one kind and the p2 are of second kind and the pk are of the kth kind and the rest, if any, are of different kind is n factorial divided by p1 factorial, p2 factorial and pk factorial. Theorem number 3 na kai haige haibakanda nangi n objects sigi manungda p1 se p1 object se masak manaba khara yaure, p2 object sigi masak manaba khara me yaure ko, pk habadugi masak manaba object khara yauragadi nangi total number of permutations se kaina pirakani n factorial divided by p1 factorial. p1 factorial habase kaina p1 se nangi object se repeated tawbo masing duni ko, p2 factorial, pk factorial. Example seeing siko. Find the number of permutations of the letters of the word Allahabad. Solution: there are 9 letters in the word Allahabad. Nangon da hosik putoka du se kaino number of permutations of the letters of the word Allahabad habaneba. Allahabad haba word se the yarba letter mayam se da tungan ba position se change tawraganda nangi permutation se kya puthokpa yagi hangbani ko. Allahabad haba se yarba letter sing se distinct oideba. L se anirag repeat tawi, A se kyarak repeat tawi, ahumrag repeat tawi ko. Sumaina nangi object sing se repeated yauramagadi total number of permutations se kaina pigani haba concept sing se. Here there are 9 letters in the word Allahabad. Nangi Allahabad habis the letters kya yawi mapan yawi ko 1 2 3 4 5 6 7 8 9 9 yawi ba. 9 yawi sigi matung the of which there are 4 appears. There are 4 is nangi A se masing kya yawi ama ani ahum mari yawi ko. Duna letter A appears 4 times and a letter L appear 2 times. L se kya repeat tawi anirag repeat tawre ko. Sumaina nangi A have a letter se marirag yaure, L have a letter se anirag yaure, and the rest are all different. Aduga lehauriba remaining letters sings diloina different ore ko. And so the required number of permutations or arrangement is given by n factorial number of letters se 9 natra divided by nangi 4 se A se kyarak repeat tawgi 4 have natra 4 factorial na divide tawgani ba. Aduga nangi L se kyarak repeat tawi 2 times ni ko 2 factorial. Sina ahan bagi first kind do ore, sina second kind do ore ko. Total number of permutation is given by 9 factorial divided by 4 factorial into 2 factorial since the letter A appears 4 times and the letter 2 appears 2 times. Sumaina nangi letter natrago object se repeated oiragadi number of repetition dugi factorials na divide tawgadaba. 9 factorial 4 bao reduce tawsiko 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial. 2 factorial is the product of 2 and 1. Si 4 cancel tawre duga sigi 6 the 2 na divide or the 3 tare ko, and product of 9 8 7 3 and 5 is equal to 7 5 6 0. Sumaina nangi object sing se distinct oidraga di theorem number 3 ga theorem number 4 ga apply tawgani. Next, we are going to solve question number 3 of exercise 7.3. Question 3 si question pasiko. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6 and 7 if no digit is repeated? Nangi digits se repeat tawba yadragadi. Even number 3-digit oiba even numbers kya form tawba yagi heba. Nangi sizinnagadaba digit se 1 ne 2 ne 3 ne 4 ne 6 ka 7 ka sipire ko. The 3-digit numbers habanina nangon the vacant place kya laigani vacant place ahum laitare. Here we are going to find all the possible 3-digit even numbers by using the digits. Karamba digit use tawgani 1 2 3 4 6 and 7. without repeating its digits. Nangi digits singse repeat yabra, repetition yade ko. And nangi nangna hujik fill up to say 3-digit number neva. Do the vacant place ahum leibam to eko. Unit place, 10 place, and 100 place haibam. Question the even number haibam pyramid even number hai se karam kanda oini. Nangi unit place the even digits katan of kupai tawrakan oigadavane. Since a number is an even number if the unit's place is occupied by the even digits only. Sigi mafam se even digit khatang na occupy tawrakan oigadavane. Aduna nangi given digits in the even numbers masing kya yawe. There are 3 even digits. They are 2, 4, and 6 minus digits ahum yawe ko. The unit place se ways kya da fill up tawba yagani. This unit place can be filled up in 3p1 ways. Havadi permutation of the 3 objects taken one at a time havani ko. Ahum leibasigi manungda ama di lawganiba. Ama do lawraga nangi unit place se fill up tawgadavani. And since the digits cannot be repeated, nangi digits se repeat tawba yabra yade ko. Nangi total number of digits se kya no 1, 2, 3, 4, 5, 6 ni ko. Since the digit cannot be repeated, and so total number of digits is reduced to 5. 5 to reduce the ugrani, and the remaining 2 places can be filled up in nangi lemhoriba mafam ani sa kaida fill up tawba yani 5p2 sinang na lawduri so object ani ni ko. Total number available sina kya leire manga leire. Aduna unit place sina 3p1 ways da fill up tawba matamda remaining 2 vacant places se ways kya da fill up tawba yagani 5p2 ways da fill up tawba yarani ko. C fill up tawba na 3p1 remaining ani se fill up tawba na 5p2 tare, and therefore by the multiplication principle total possible numbers nangi total possible arrangement se kaina pigani 5p2 into 3p1 sina pirani ko. 5 factorial divided by 5 minus 2 3 factorial tare ko into 3 factorial divided by 3 minus 1 is equal to 2 factorial. Sigi 5 se 3 bo reduce to siko 5 into 4 into 3 factorial by 3 factorial into 3 into 2 factorial divided by 2 factorial. Si cancel tawre 3 cancel tawre ko 5 4 20 into 3 ama laizare product se kya gamanare 60 tare ko. Sida nangi total number of 3 digit even numbers to ni kanana form tawba 1 ne 2 ne 3 ne 4 ne 6 ne 7 ne. Gyan tarani ko. Next question, question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Nangi committee em leire, committee sida mi nipan yaure ko. Sida mafam ani leire, chairman ga vice chairman ga. Chairman vice chairman se mi amana animak oisenbe ade ko, ama tongan ba mafam oigadabani. Si kamain tawraga choose tawgadoino haiba. Question number 8. We are going to choose a chairman and a vice chairman from a committee of the 8 persons, assuming one person cannot hold more than one position. Means nang objects repeated tawba yadi haibaga meaning manai ko. Dudi mafam kya na hojik nangon hangi se mafam ani ni. Chairman haiba maga vice chairman haiba ko. Dusina chairman gi position oi resina vice chairman gi position oi baganda nangi committee sida mi masing kya yawi mi nipan yawi ko. Aduna ahanbagi se fill up tawba matamdadi mi nipan dugi manungda amana dum oiba yadra. Aduna the position of the chairman can be filled up in 8p1. Si ahanbagi se mi nipan gi manungda ama khanba yaiba. Selection of one person out of 8 can be done in 8p1 ways. 8p1 de yare ko. And the position nangi objects repeat tawba yade sida ko, since one person cannot hold more than one position, and so the second position vice chairman position can be filled up in 7 to ama chatki tardi 8 to ama chatki tardi 7 da hanthare ko. 7p1 ways la aniba. Ahan bagi sina 8p1 da fill up tawba yare, aduga ani subagi sina 7p1 da chumana reduce tawba yare ko. And so the position of the vice chairman can be filled up in 7p1 ways. Therefore, total possible ways is equal to nangise multiplication rule palini ko. Ahanbagi fill up tawba sina 8p1 ani subagi sina 7p1 na 8p1 into 7p1 tare, which is equal to 8 factorial by 8 minus 1, 7 factorial into 7 factorial by 7 minus 1 is equal to 6 factorial. 8 into 8 से 7 the reduce tawre ko. 7 से 6 the reduce tawre ani se cancel tawradi 8 into 7 product से क्या फंगे 56. नंगे chairman ga vice chairman ga ꯑꯅꯤꯁꯤꯒꯤ ꯄꯣꯖꯤꯁꯟ fill up ꯇꯧꯕꯁꯦ ways ꯀꯌꯥꯗ fill up ꯇꯧꯕ ꯌꯥꯒꯅꯤ 56 ways ꯗ fill up ꯇꯧꯕ ꯌꯥꯔꯅꯤꯀꯣ next question number 6 find p if permutation of n minus 1 taken 3 at a time n minus 1 p3 is to n p4 is equal to 1 is to 9 nangonda sida nangonda condition khara pireko habati permutation of n minus 1 objects taken 3 at a time is to np4 permutation of the n objects taken 4 at a time is equal to 1 is to 9 is to haise divide ni ko n minus 1 p3 sige expression se kai ga manani n minus 1 factorial divided by n minus 1 minus 3 factorial is to n factorial divided by n minus 4 factorial r is the 4 chale ko is equal to 1 by 9 n minus 1 factorial by n minus 4 factorial into sigi is 2 se into lakpa kanda reciprocal logani ko take the reciprocal of this expression n minus 4 factorial divided by n factorial which is equal to 1 by 9 judi sida sigi n minus 4 cancel to where we have n minus 1 factorial divided by n factorial and this n factorial is reduced to n minus 1 n minus 1 factorial is equal to 1 by 9 and this cancel to where we have 1 by 9 is equal to 1 by n is equal to 1 by 9 manaradra by cross multiplication or taking reciprocal on both sides we have the value of n is equal to 9 sumai tawraga khoina puthokpa yagani n minus 1 p3 gi formula irani n p4 gi formula irani is to means divide ni ko into on bakanda reciprocal or take the reciprocal of second expression duga khoina n gi value puthoani mathangi question se question number 7 find the value of r gi value putho have ko if 5pr is equal to 2 into 6pr minus 1 5pr means permutations of the 5 objects taken are at a time is equal to 2 into permutations of the 6 objects taken are minus 1 object have sigi permutation gi khoi gi expression ji sijinarage expand tawsiko 5pr have se kamaina ithokpa yai 5 factorial divided by 5 minus r factorial which is equal to 2 into 6 factorial divided by 6 minus r minus 1 equal 6 factorial divided by 6 minus r minus plus darani factorial 5 factorial by 5 minus r factorial is equal to 2 into 6 factorial by 6 plus 1 7 dareko 7 minus r factorial by cross multiplication sigi 7 minus r se left to in thamsiko 7 minus r factorial divided by 5 minus r factorial is equal to 2 into 6 factorial divided by 5 factorial cross multiplication lae then 5 ka 7 ga kanan chawbe heli 7 minus r is greater than 5 minus r so reduce this 7 minus r up to 5 5 or reduce to 7 minus r minus 1 will be equal to 6 minus r and 6 minus r minus 1 will be equal to 5 minus r factorial reduce to a divided by 5 minus r factorial 2 into 6 sigi 6 factorial se 5 factorial da mu reduce to re ko 5 or reduce to re divided by 5 se cancel to na be are ni se cancel to na be are we have 7 minus r 6 minus r is equal to 12 product holo 14 minus 7 r minus 6 r plus minus plus tare ko r square is equal to 12 r square ani se punjin baze 13 r tare 42 minus 12 0 chale ko r square minus 13 r plus 30 equals to 0 se quadratic equation amne which is a quadratic equation in r ni ko quadratic equation solve to was a splitting method na solve to rasi now we are going to find two numbers whose product is 10 and their sum is equal to minus 13 which implies that the two numbers are both negative animak se negative ngak to oigadabani ko duna number ani se 10 ga minus 3 ga lore yadi minus 13 can be expressed as minus 10r minus 3r plus 30 equals to 0 chale ko sigi ahan bagi expression si da r common lagtho e r minus 10 tare last two expression si da minus 3 common lagtho adi r minus 10 0 phange ko r minus 10 se common lawradi r minus 3 is equal to 0 sigi se akhona solve tawba matamda r gi value se 3 ga 10 ga phangeba nangonda piriba permutation se object manga ne amana object taruk ne adudi nangi se r gi value se 10 taba yabra yade ko 10 sidi nangonda piriba total number of object gi hen greba aduna si neglect tawre ko 10 se neglect tawrakanda possible values of r se 3 oigadaba since r cannot be greater than the value of n that is 5 or 6 nangi r gi value se 5 ka 6 tagi hen ba yade ko nangonda piri se 5 ka 6 kani sidagi lawgadabane maximum da 5 taba ye atopa mana 6 taba ye mathangi question amu yengasi next question number 9 how many words with or without meaning can be made from the letters of the word Monday assuming that no letter is repeated if 4 letters are used at a time. Number 2, all the letters used at a time. Number 4, all letters are used but the first letter is a vowel. Sumaina condition ahum pireko. Monday has the letters masing kya yawi Monday sida repeated over letters yaw braina khoina khangdo aniba. Adugi matungda letter ahum use tawba. Letter taruk makse use tawba. Aduga letter se loin use tawraga nangi first letter se kaina mamang thangan gadaba vowel na oigadaba. Sumaina condition ahum laireko asimu yengasi. Question number 9. There are 6 different letters. There are 6 different letters in the word Monday. Monday have a word se they are letter ma'am se repeat tawde loina different oiko. Adi manaba hanjin ba yawdeba. Tugi Roman number 1 case the 4 letters used at a time. Nangi 6 letters sigi manungda letters taru ahum mari khaktamak sizinaragadi total number of permutation se kya laiba yai haibani ko chimu yengasi. If the 4 letters used at a time 4 letters used at a time, comma, then the total possible words is equal to permutations of the 6 objects taken for at a time. Chigamanareko, which is equal to P64. Theorem gi matungina kaina pirani 6 factorial divided by 6 minus 4 is equal to 2 factorial. 6 factorial have a second reduced to 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial. Any se cancel tawre. Yudi 6, 5, 4, 3 ahum ze loina product holagadi 6 ka 5 ka gi 30 imlere ko 4 ka 3 ka gi 12 product of 30 and 32 is equal to 360 sumain tawraga nangi letter taruk laibasida mari khaktang sizinaragadi permutation of 6 objects taken for at a time sigi formula se khoina sizinarani ko. Number 2 da all letters used at a time. Nangi letters taruk makse loin sizinaragadi nangi total number of permutation se kya lakpa yai simu yengsiko. If all the letters used at a time, then the total possible words is equal to permutations of the 6 objects taken 6 at a time. Nangi 6 laibagi manungda 6 lawbusiga manarani, which is equal to 6 factorial divided by 6 minus 6, 0 factorial tareko is equal to 6 factorial. 6 factorial haidi kaino the continued product of 4 6 natural number 1 2 3 4 5 6 ki product ne kya gamanare the product of 4 6 natural number is equal to 720. Ahan bagidana object ahum use tawba handakidana object se loina use tawba ko. Number 3, all the letters are used but the first letter is a vowel. Letter khudimak se loina decision naba aduga ahan bagi letter se kai ohengadaba vowel oigadaba ko. Monday has the vowels kya yawi ani yawi ko o ga e ga ani si khaktang na sigi first position se fill up tawba yaganeba. First position, second position, third, fourth, fifth, sixth later ko. Si ahan bagi se vowels na hello hai taragadi nangi vowel ani sigi manungda amadi thamba yaniba. Duna sigi first vacant place is to be filled up by one of the vowels, that is 2, 0 or a. Sina fill up tawba yani ko. And it can be done in 2p1 ways da yani. And the letters se repeat tawba yadabani na nangi sigi remaining 5 se. Object taruk laibagi manungda object ama lawthokradi 5 lemhawidana. The remaining 5 vacant places can be filled up in 5p5 ways. Sidamuk fill up yaduini ko. If the first letter is a vowel, nangi ahanba letters in a vowel oitaragadi, the first place can be filled up in 2p1 ways. Sida fill up tawba yagani. The remaining 5 places can be filled up in 5p5 ways. Repetition yadabani na vowel ama thamgi tardi vowel taruk tagi ama lawthokradi manga laire ko. ꯅꯪꯒꯤ ꯑꯣꯕꯖꯦꯛ ꯇꯔꯨꯛꯇꯨꯗꯒꯤ ꯑꯣꯕꯖꯦꯛ ꯑꯃ ꯂꯧꯊꯣꯛꯈ꯭ꯔꯗꯤ ꯃꯉꯥ ꯈꯛꯇ ꯉꯥꯏꯍꯧꯔꯦꯀꯣ ꯑꯗꯨꯅ remaining 5 vacant places can be filled up in 5p5 ways. ꯑꯍꯥꯟꯕꯒꯤꯁꯤꯅ 2p1 ꯗ 2 ꯁꯦ ꯀꯩꯒꯤꯅꯣ ꯍꯥꯏꯔꯗꯤ number of vowels ꯁꯦ ꯑꯅꯤ ꯑꯣꯏꯕꯒꯤ ꯑꯅꯤꯁꯤꯒꯤ ꯃꯅꯨꯡꯗ ꯑꯃ ꯂꯧꯒꯗꯕ ꯑꯗꯨꯒ ꯅꯪꯒꯤ remaining 5 ꯁꯤꯅ 5 ꯂꯩꯕꯒꯤ ꯃꯅꯨꯡꯗ 5 ꯁꯤ ꯃꯔꯛꯇ vowel ꯇꯥꯕ ꯌꯥꯏ vowel ꯅꯠꯇꯕ ꯌꯥꯏ ꯀꯩꯁꯨ ꯀꯥꯏꯗꯦꯀꯣ and so total possible ways is given by the multiplication rule and which is equal to 2p1 into 5p5 factorial. 2p1 means 2 factorial divided by 1 factorial and 5 factorial by 0 factorial. Sigi product hotpa kanda 240 habisi tani ko. Nangi Monday haba word CDR letters mayam se ahan bagi se nangi vowel 0 natraga o natraga a na haubo matamda nangi total possible words se kya puthokpe yani 240 puthokpe yani ko. Last question is question number 10. Question 10 question pass. In how many of the distinct permutations of the letters in Mississippi do the four I's not come together? Nangi Mississippi haba letters sama nangon pireba. Mississippi si the letters am hanjile ko. Sige hanjinba letters mayam si sizinaraga. Nangi I mari se pulap punna layhandragadi. Total possible outcomes kya layduino haba. Find the permutations of all the letters in the word Mississippi when the four I's do not come together. I mari yawi ko nangi Mississippi sida. Mississippi sida yawi se 1, 2, 3, 4 I mari hanjile. A su kya hanjile mari P su anirak hanjile ko. Si mayam se ani ito se. There are 11 letters in the word Mississippi, of which the letter I appears 4 times, the letter S appears 4 times, and the letter P appears 2 times. Nangi P se repeat away 2 times repeat away ko. And here we are going to find all the possible arrangements when the four I's do not come together. Sigi I mari se punna layminadaba haiba. I mari se punna layminadabida koina total possible arrangement kya puthokpa yagi haibaduni ko. Si koina kamai hotkani the total permutations when the four I's do not come together haibase. Ahanbada without any restriction da koina total possible outcomes puthoaniba. Total possible arrangements made by all the letters in the word Mississippi dudagi I mari punjin bagi arrangement se khaido aga phangdoini ko. Du concept se yangasi. There are 11 letters in the word Mississippi, of which the letter I appears 4 times. Nangi letter I se kyarak repeat away 4 times ko. S appears 4 times and the P appears 2 times. P na kyarak repeat away 2 times repeat away ko. Here we are going to find all the possible arrangement when the four I's do not occur together. Sineba. Without any restriction amta P da vida total possible permutations of the letters is equal to kya gamanani 11 factorial. Si masing si 11 ni ko nangi number of repetitions na divide tawrakadaba. 4 factorial into 2 factorial. Si 4 se letter I se repeat tawbagi sigi 4 se letter A se repeat tawbagi aduga 2 sina P repeat tawbagi ni ko. And if the four I's come together nangi I mari se pulap punna thammagadi. Sigi arrangement se hanamuk yengduni ko. If the four I's come together, then they can be considered as one object. Object ama khatane na khanba yai ko. This single object together with the remaining objects. This single object together with the remaining 7 objects. Si objects se pull up laminar dimasi ama khatane na khale. Adudi 7 letters sama lehaudra. 7 letters lehawi ko. Adudi 7 plus 1 kya tagre 8 ne na count tore. This single object together with the remaining 7 objects can be counted as 8 objects and can be arranged in ways kya de arranged tawbuyai 8 factorial divided by 4 factorial and 2 factorial. Si 4 factorial se kaidai la ino nangi letter A se mari rak repeat tawe duga letter P se kya rak repeat tawe 2 times repeat tawe ko into sigi I se kya no mari natra mari se tuan ba different position change tawrasu arrangement sa amadagi na phangde kaigino nangi letter sing se masak loi manai ko aduna magi di permutation se 1 khatang tabane and therefore total permutations when the four I's do not occur together nangi I mari punjin bado ama khatane na khale siga object siga remaining 7 siga punjin base 8 ne na khale ko aduga 8 object se kaide arrange tawbu yare 8 factorial divided by 4 factorial into 2 factorial, and these 4 i's can be arranged in only one way. One way dagi hena yade ko masak chap manabanina. Duna sigi nangi I mari na punjillaga semba total possible arrangement se oireba. Hause aina pambadi kaino I mari se punjinadabi tongan tongan leibaduni ko. Hence, the total permutations when the 4 i's do not occur together is equal to permutations of the letters in the word Mississippi without any restriction. Restriction amta leitabida puthokadaba permutation to oina itare ko 11 factorial by 4 factorial 4 factorial 2 factorial minus the total number of permutations when the 4 i's occur together is the big ko aduga koina ani se anka hole 11 factorial se 4 बाउ reduce तौरे दुगे 11 10 9 8 7 6 5 दुगे सिगी 4 factorial से 4 into 3 into 2 into 2 द इरे को 8 factorial से 4 बाउ reduce तौरे 2 factorial से 2 गा 1 गा की product नि दुगा सिदा लेम हौरी से सिगी 4 गा सिदा का इसे 6 को 2 3 की 6 अमा ताजगरे 4 सिना 4 गा 2 गा अमा पुनबगी 8 सिमा cancel तौगरे को लेम हौरिसे 11 10 9 7 5 लेमे second expression दना 8 7 3 5 लेमे product होले को दुगा अनि से खाइदोकनाबदा 33810 सी फंगे. For today, let's end here.